Hi, I'm Blake, Managing Director of WMS Engineering, and this is...
Hey, I'm Mark. I'm the Principal Engineer at WMS Engineering.
And today we're going to talk about bridges and how we determine how long they are.
Why are some of these bridges so high? I don't know, do you?
Well, that's why I've got you.
Maybe I do know.
Hey Mark, how long is a piece of bridge?
I don't know, let's measure it out, Blake.
So Mark, tell us, how did you work out it's got to be this wide? Because look, the creek's only this wide. And as we know, every extra metre of bridge you got is very expensive to build, slower to build than the road, and whoever owns this bridge is going to have to maintain it.
Good question, Blake. I mean, like in a flood event, obviously it's more than the creek that is going to see rising waters, and we activate the floodplain and the high channel locations, and then we've got to consider that this bridge, if we build the embankments into these low-lying floodplains, we have higher expansion and contraction going through the bridge, which raises the flood levels upstream, potentially affecting properties in nearby locations.
You're balancing the length of the bridge with how much impact we're potentially having to people upstream. So we don't want to impact anyone upstream and make it worse for them. We don't want to make it any worse downstream, and you're balancing that length out.
Exactly right, and there's also bridge immunity requirements to consider. So obviously the more constricted we make the waterway, the more that pushes up the flood level, and the higher the bridge has to go again to compensate for that. So
okay.
It's a delicate balancing act to try and fit within the constraints of the specific floodplain.
So Mark, these piles, bridge piles you've drawn here, how do we take those into consideration, and what do we have to worry about? Because obviously these guys are sitting in the waterway, and there's going to be a lot of water going past them.
Yeah, of course. So when we model the bridges, we include the piers in that modelling calculation, and those get accounted for in the form losses and blockage factors applied to the under-bridge area. So obviously as the water rises, those piers contribute to the sort of impedance to flow, and we've got to account for that in our modelling.
And what about this? This is the handrail you've put in up the top here.
Yep.
Is that accounted for in the same way? It's got big gaps in the middle of it. Tell me what happens when the flood comes through.
That also obviously has to be accounted for. There's certain blockage factors that you can apply to different railings. As the flood water approaches the deck, you have large amounts of afflux. When it overtops the deck and gets drowned out, the afflux difference between the upstream and downstream water levels is less pronounced.
Ah, so you're saying it's not as bad when a big flood comes through, but it's worse when a medium-sized flood?
Yeah, so it depends what flood event you're designing for, and at times it can be preferable to actually have a low-level crossing so that any significant flood event drowns out that crossing and doesn't cause impacts nearby. But of course that would be more appropriate potentially for pedestrian bridges or bridges that are certainly not going to be in use. For trafficable bridges, vehicle bridges, there's minimum immunity requirements which may limit the amount to which you can do that.
And knowing that these things are very expensive, building a bridge, very expensive to build and maintain, how do you go about making sure that you don't make it any longer than what it needs to be for the person paying for that piece of infrastructure? And how do you balance making sure it's the right width so that you do able to keep the flood immunity that you're after?
I mean, there's occasionally a bit of an iterative approach to your bridge testing. You're dealing with the constraints at hand and the client's requirements in terms of materials and bridge spans that they might prefer to use, and the designers. Ideally, you want to be honing in on the size of the bridge that is going to satisfy all your criteria without making it bigger than necessary. And it's just a matter of putting that in the model and testing those scenarios.
When you're doing that, you just put it in the model and it just does all that for you and it spits out the answer.
So obviously in any sort of modelling, the data you put in is important to the data you get out. So you want to be parameterising your model well and then validating your model. And in terms of hydrology and hydraulic modelling, if the data is available, we do a calibration wherever feasible.
If I wanted to change, some of the design or my client someone who's designing something, my client came to me and said, "I now want a higher immunity." What would that mean for you as the hydraulic engineer on the project?
Yeah, so I mean, I suppose as flood engineers, we always encourage higher immunities. It's important for people to realise that a bigger event can always happen. It's just a matter of the probability of these events occurring. So when the client requires these higher immunities, we can go back and